Hi, I'm an old guy and I do maths. Today we're looking at Z or Z-scores, if you want to call them that. Another term is standardized score or standard scores. This is the formula for such a thing here, and we'll come to this in a minute. But you shouldn't really be looking at this without a decent understanding of what a normal distribution is. Here's one. And what a standard deviation is. So these lines here represent standard deviations within a normal distribution. So if all of that makes no sense to you, you should probably go and have a look at the other videos in this playlist on standard deviations and normal distributions. If it makes sense, well, away we go. Okay, so what a Z-score does is it gives you an accurate measurement of the distance between the mean, which is this point here in the middle of the normal distribution, and a score. So, for instance, if the score that we're interested in, let's just say that this is the results of an exam or something, the score that we're interested in, this one, we can see is, just from my drawing, approximately 1.5 standard deviations away from the mean. And that's useful and important information, again, which I will explain in a moment. So how do we calculate this thing? Well, this x represents, for instance, a score like this. So if we say that this is 50 and that the standard deviations are, what shall we say, 15. So this standard deviation would be at 65 and this one would be at 80. And let's just say that we've got a score of 75%. Now, we know that that's greater than the mean. What is its Z-score? Well, it is 75, which is this value here, minus 50 over 15. Which gives us, 25 over 15, which gives us, 5s into that are 5 over 3, so that is 1.66 standard deviations above the mean. Now, why is such a thing of interest to us? Well, there are any number of reasons, but I'd like to give you a practical example that comes from my career at high school, and this is it. Now, in my class, in I forget what year it was at high school, both mathematics and physics were compulsory. So the same group of people studied mathematics and physics. And we all sat an exam at the end of the year. And what I've done is I've taken a hypothetical mark for the exams in each case. These are not my results. My math score was higher, let's put it that way. I didn't like physics. Okay, so what can we see here? Well, what we can see is that the range of maths scores hypothetically ran from 0 to 100, and the range of physics scores ran from 0 to 70. Now, these do not reflect just my class's results. They reflect a much broader set of results, because the exams that we sat were external exams. And so this is actually supposedly representative of the entire population of students that year sitting this subject and this subject. And what you notice is that the scores for physics are much more tightly packed. The range is from 0 to 70. And so when I get my results in the mail, as we used to in those days, and I open them up, and I see that my marks approximate these, the first thing I'm going to think is, oh my, I did really bad at physics. I did really badly at physics. I suppose on a first glance you could say that, but let's see where 90% puts me in a normal distribution. It would be somewhere around here. Where does 65 put me on the normal distribution for physics? Somewhere around here. What I've been able to do is I've been able to locate my marks on each of these normal distributions. And if I were measuring the distance in standard deviations from this mark to the mean, it would be 1, 2, 3, we'll say 3.1. So that puts me here in a very small group of people. And despite the mark that I get here, the distance between my mark and the mean is 1, 2, 3, we'll say 3.1. It could be 3.2. It's 3.1 standard deviations from the mean. So what I've been able to do is I've been able to, as they say, compare an apple with an orange. And the fact is that by common consent, this exam was way, way harder than this exam. And so the scores were lower and more tightly packed. But if I'm looking at a way to compare myself against my classmates, what I can do is I can calculate my Z-score, which I'm not going to do for these. You've seen me do a quick calculation up here, and you've seen the formula for it. But if I were to calculate it and I got 3.1 and 3.1 for each, what I would see is that I am sitting in roughly the same position vis-a-vis my classmates in each of these subjects. And so 65 doesn't tell the whole story. You need to know what that was. You need to know what the standard deviations and what the mean was. I imagine if the mean here was 50, the mean here was probably about 35. And that's really, really something interesting to consider. Anyway, to return to the mechanics of the Z-score, what you need is you need a particular score, you need a mean, and you need a standard deviation. And what this tells you is how far from the mean your score is, whether it is here or whether it is here. You can have a negative one, you can have a positive one. I hope that this was a helpful and useful introduction to Z or standardized scores. Thanks very much for watching. See you next time.